What is up, everybody? Welcome to my YouTube channel. This is MBS here. Thank you for your response on my previous video, guys. I'm not going to waste your time. Let's get started. Hey, what is up, everybody? Okay, now you have seen the scene, right? Let's see some basic structures. Afterward, we see the medicine behind the scene. Okay. First of all, you have to know what is retina. See, this is the basic arrangement of retina, guys. This was since we are going to focus on the central pathway, we are not much bothered about the retina. If you want a specific topic, specific lecture on retina. Okay, this is the 10 layers of retina, guys, and see here, this is the ganglionic cells. These are the ganglionic cells. Okay, the ganglionic cells are actually two types, guys. A smaller one is called a P cell ganglion. A larger one is called M cell ganglion. Okay, guys, and see, this is peripheral retina, guys. This is peripheral retina and this is central retina. This is peripheral retina and this is central retina, guys. Central retina contains only the cones. Okay, and you know the peripheral retina has various number of layers. The central retina contains only 3 layers, guys. The cones and the amacrine cells and the ganglionic cells. So the visual acuity in central retina was higher when compared to the peripheral retina. Okay, this is a retinal structure. Now from the ganglionic cells, see, these are the optic nerves. From the ganglionic cells, the impulses are going via the optic nerve. Okay, let's write from ganglion cells to the optic nerve. From here, they are going to the optic chiasma. Here is a big deal, guys. Let me explain this. See, this is your left eye and this is your right eye. Okay, this is the visual field. These are the visual field. Okay, while we dividing the visual field into two, this is nasal half of visual field and this is the temporal half of visual field. Here's the trick, guys. Listen carefully. See, the temporal half of visual field is taken by the nasal half of the retina, while the nasal half of visual field is taken by the temporal half of retina, guys. Okay, be crystal clear in this concept. Temporal half is taken by the nasal retina and nasal half is taken by the temporal retina. Okay, so the impulses are taken from the ganglion cells via the optic nerve to the optic chiasma. See, this is the optic chiasma, guys. In the optic chiasma, there's another trick. See, in the optic chiasma, the temporal half, right? The temporal retina, they don't decussate, but the nasal retina will decussate. See, follow the blue lines, guys. The blue lines are the nasal half. See, the nasal half are actually decussating. The nasal half passes contralaterally. So what will happen means, while we coming to the optic, after we are leaving the optic chiasma, which means the optic tract, we got the temporal half of left eye, and the nasal half of right eye. See the red fibers, they just crossing in the optic chiasma, and as a whole we got in the optic tract is a temporal half of left eye and the nasal half of right eye. Okay, guys. Okay, let's get to from optic chiasma. For instance, we are going to take about our right eye. Okay, right eye. For in a case of right eye, okay, right eye, in the optic tract, we have the right side temporal half of retina and the left side nasal half of retina. Simple, right? Very simple. Okay, now let's see. Okay, from the optic tract they are actually going to the LGN, which is nothing but the lateral geniculate body. LGN, just nothing but the lateral geniculate body. Here we can see the lateral geniculate body. See the lateral geniculate, here is the lateral geniculate body. There is two, right? Medial geniculate body, lateral geniculate body. Medial geniculate body is mostly concerned with the auditory, audition, I mean your audio, but the lateral geniculate body is mostly concerned with your visual. Okay. In the lateral geniculate body, we got number of layers. It has 6 layers, guys. It got 6 layers in lateral geniculate body. Okay, let's see. As I mentioned before, the M cell ganglion, right? The M cell ganglions are larger ganglions, while the P cell ganglions are smaller ganglions. So the M cell ganglions are the pathway is also known as the magnocellular pathway. Magnocellular pathway. They are called as parvocellular pathway. Okay, so the magnocellular pathway and parvocellular pathway. Okay, as you've seen here, the layer 1 and 2 are occupied by the M ganglion cell, where the rest of the layers are occupied by the P ganglion cell. Very simple, right? The layer 1 and 2 are occupied by M ganglion cell, rest of them are occupied by P ganglion cell. Now, see, we are going to see about some differences between them. Okay, let's see. M ganglion here and a P ganglion. The M ganglion cells, right? The M ganglion carry only the black and white color, guys. They carry only the black and white color, whereas P ganglion cell carries the color vision. They are responsible for the color vision. Okay, and number 1. Number 2, the M ganglionic cells has higher velocity. They are higher velocity, while compared to the P ganglionic cells, they have lower velocity. Okay, then third point, the point-to-point transmission in M ganglion cell is very poor, while in P ganglionic cell, high efficient. Point-to-point transmission is high efficient. These are some of the differences we have to know, guys. Okay, and other than these layers, the LGN, the LGB, the lateral geniculate body has intralaminar portion. We will see what is the function of this intralaminar portion, first layer, second layer, and the rest of the layers. Okay, now we reached the lateral geniculate body. From the lateral geniculate body, they are going to the primary auditory cortex. Brodmann AS number is 17. Okay, so via optic radiation, they are going to the primary auditory cortex. Okay, primary auditory cortex. Let's see. The primary auditory cortex, as I mentioned before, there are 2 retinas, right? The peripheral retina and a central retina. Okay, from the peripheral retina, they are going to the superior lip and inferior lip of the calcareous fissure. See, this is the calcareous fissure, and this is the superior lip, and this is the inferior lip. So these places are occupied by the peripheral retina, while central retina is actually occupying the most posterior parts of the primary auditory cortex. Primary visual cortex.